The world you see around you right now is probably a lie. Not a small lie, not a simple optical illusion that tricks the eye, but a fundamental structural deception that is hardwired into your brain. You have been told since you were a child that you live in a three-dimensional world. You look at your hand, and you see depth. You look at the room around you, and you perceive volume. You believe that you can move up, down, left, right, forward, and backward. This feeling of depth seems definitive. It seems like the most obvious, undeniable fact of your existence. But what if I told you that depth is not real? What if the third dimension is not a fundamental feature of nature, but a user interface created by your senses to help you navigate a reality that is actually flat? Physicists working on the bleeding edge of quantum gravity are beginning to uncover a startling possibility. The universe might not be a vast, deep ocean of space as we perceive it. Instead, it might be a projection, a hologram. This does not mean you are living in a computer simulation like the Matrix. The holographic principle is far more subtle and far more disturbing than science fiction. It suggests that the real you, the data that makes up your atoms, your memories, and your life, is not located here, in this room. It is located somewhere else, somewhere far away on a distant two-dimensional surface at the edge of the universe. And what you think is you, right now, is merely a shadow cast by that distant data. In this series, we are going to dismantle your perception of reality. We are going to explore why gravity might be an illusion, why space might be made of pixels, and why the universe is essentially a cosmic hard drive. But first, we must understand why your intuition about the world is wrong. Let us begin with the definition of real. When you touch the table in front of you, it feels solid. It feels continuous. You press your finger against it, and it stops. Your intuition tells you that the table is filled with stuff, dense, hard matter. But physics tells us this is an illusion. If you were to zoom in on the atoms of that table, you would find mostly emptiness. 99.99999% of an atom is empty space. If the nucleus of an atom were the size of a marble sitting in the middle of a football stadium, the electrons would be tiny specks of dust orbiting in the furthest stands. The rest is nothing. So why can't your hand pass through the table? It is not because the table is full. It is because of force fields. The electromagnetic repulsion between the electrons in your hand and the electrons in the table creates a resistance. What you feel as solid is not matter. It is a force. It is information telling your brain, do not go further. This is the first crack in the glass. It reveals that our senses do not show us reality as it is. They show us a useful summary. They show us a desktop icon, not the code running underneath. Now, apply this logic to space itself. We think of space as a container, a smooth, continuous stage where events happen. We assume that if we zoom in on space, we will just find more space, smaller and smaller chunks of it, infinitely. But just like the solid table, this assumption of smooth, continuous space is likely wrong. When we try to combine our two best theories of physics, quantum mechanics, which describes the small, and general relativity, which describes the large, we run into a catastrophe. The equations break down. They give us infinities. And in physics, when an equation gives you infinity, that is not nature telling you something about the universe. That is mathematics telling you that your theory has failed. This failure suggests that space is not smooth. At the smallest possible scale, space must have a structure. It must be pixelated. And if space is made of pixels, then the universe has a limit to how much information it can hold. It has a resolution. To understand why the three-dimensional world is an illusion, we have to look at the place where three-dimensional space is destroyed. We have to look at the black hole. For decades, physicists struggled with a problem called the information paradox. The problem is simple. Quantum mechanics says information cannot be destroyed. If you burn a book, the information in the book is not technically lost. If you could collect every photon of light, every particle of ash, and every molecule of smoke, you could, in theory, reconstruct the book. The information is scrambled, but it is still there. But a black hole is different. According to classical general relativity, If you throw a book into a black hole, it crosses the event horizon and is crushed into the singularity. It vanishes. And when the black hole eventually evaporates through Hawking radiation, that radiation is thermal. It is random. It carries no memory of the book. The information seems to be deleted from the universe. This terrified physicists. If information can be deleted, then the past does not determine the future. The entire structure of physics collapses. So, a war began. A war between Stephen Hawking, who said information is lost, and Leonard Susskind, who said it must be preserved. The solution that ended the war was strange, it was radical, and it changed our view of reality forever. Susskind and others realized that when an object falls into a black hole, its information is not lost inside. Instead, the information is smeared across the surface of the event horizon. Think of a can of soup. If you want to know what is in the can, the ingredients, the calories, the flavor, you do not need to dive into the soup. You just need to read the label on the outside. The label is two-dimensional, the soup is three-dimensional. But the two-dimensional label contains all the information necessary to describe the three-dimensional soup. This is what a black hole does. It acts like a cosmic soup can. The entropy, or the amount of information of a black hole, is not proportional to its volume. It is not proportional to how much space is inside. It is proportional to its surface area, the size of the boundary. This was a shock. In our everyday three-dimensional world, if you double the size of a box, you can fit 8 times more stuff inside. Volume scales with the cube. But for a black hole, the information scales with the square. It scales like a surface. This implies that the interior of the black hole, the three-dimensional depth that you would experience if you fell in, is mathematically redundant. It is a projection. The real physics is happening on the two-dimensional shell. Now, here is the leap that hurts the brain. If this surface area rule applies to black holes, why wouldn't it apply to the rest of the universe? After all, a black hole is just a region of extreme gravity. It is still part of our universe. The laws of physics should be consistent. This led to the holographic principle, proposed by Gerard 't Hooft and Leonard Susskind. It suggests that the entire universe, every star, every galaxy, every planet, and you, can be mathematically described by information stored on a distant two-dimensional boundary that surrounds us. Imagine a snow globe. We are the snowflakes inside. We think we are floating in a deep three-dimensional space. We think we are moving forward and backward. But in this theory, the code that defines the snowflake is actually written on the glass shell of the globe. When the snowflake moves in 3 dimensions, it is just a translation of data moving across the two-dimensional surface. The depth you feel, the distance between you and the wall, might be a holographic projection. Just like a hologram on a credit card looks three-dimensional when you tilt it, but is actually flat, our reality might be a convincing illusion generated by the interaction of quantum fields at the edge of the cosmos. This is not just philosophy. This is a mathematical tool that physicists use today. It is called the add-CFT correspondence. It sounds technical, but the idea is profound. It proved that a world with gravity, like ours, is mathematically equivalent to a world without gravity that exists in one fewer dimension. They are two sides of the same coin. So what does this mean for us? It means that space is not the fundamental stage of reality. Space is an output. It is a result. It suggests that the universe tries to be efficient. It doesn't store data in 3D because that would be wasteful. It stores data in 2D and projects it into 3D. This explains why gravity is so hard to understand. We have been trying to find gravitons inside the 3D room, but maybe gravity doesn't exist in the room. Maybe gravity is what happens when the 2D data on the walls gets entangled. Gravity might not be a force, it might be the pixelation of the hologram. In the next part, we will dive deeper into this pixelation. We will look for the limits of resolution. We will ask the question, if we are made of information, can we be copied? Can we be deleted? And most importantly, if the universe is a hard drive, is it running out of space? Do not trust your eyes. The map is not the territory. And the territory might be flatter than you think. To find the edge of reality, we cannot look at the calm, quiet, empty space between the stars. We must look at the monsters. We must look at the places where the universe screams. We must look at black holes. For most of the 20th century, black holes were thought of as simple, destructive drains. We believed they were cosmic trash cans. Matter fell in, got crushed to a single point, and disappeared from the visible universe forever. It was violent, but it was simple. But in the 1970s, a physicist named Stephen Hawking looked closer at the darkness, and he found a contradiction that would threaten to destroy the entire foundation of physics. He discovered the information paradox. To understand why this is terrifying, you first have to understand a sacred rule of the cosmos. Information is immortal. In our everyday lives, we think we can destroy things. You can take a diary full of your secrets, throw it into a fireplace, and watch it burn to ash. You think the information in that diary is gone. But according to the laws of quantum mechanics, you are wrong. The information is not destroyed. It is merely scrambled. If you were a god, capable of tracking every single photon of light released by the fire, every single particle of soot, and every molecule of smoke, you could, in theory, run the physics backward. You could reverse the movie. You could reconstruct the ash into paper, the smoke into ink, and the light into letters. You could read the diary again. This is called unitarity. It means the past is never lost. The future is built strictly on the data of the past. But Stephen Hawking realized that black holes violate this rule. He discovered that black holes are not truly black. They glow, they radiate energy. Over incredibly long timescales, a black hole will lose mass, shrink, and eventually evaporate completely. It will vanish from the universe, leaving nothing behind but a bath of radiation. And here is the problem. The radiation that comes out of a black hole is thermal. It is random. It is chaotic. It carries no pattern. If you throw your diary into a black hole and then wait 1 trillion years for the black hole to evaporate, the radiation that is left behind contains no record of the diary. It contains no record of the star that formed the black hole. It contains no record of the civilizations that might have fallen in. The information is not scrambled. It is deleted. It is gone. This realization started a war in the world of physics. On one side, you had Stephen Hawking and general relativity, claiming that information can die. On the other side, you had Leonard Susskind and quantum mechanics, screaming that information must live. They could not both be right. If Hawking was right, then everything we knew about the quantum world was wrong. History was an illusion. Memory was not real. But if Susskind was right, then our understanding of space and gravity had to be flawed. The war lasted for decades. It was a stalemate between the two greatest theories of mankind. But eventually, the answer came, and it was stranger than anyone anticipated. To save the information, physicists had to break the concept of place. They had to break the concept of inside. Susskind and his colleagues realized that when an object falls into a black hole, a copy of its information is left behind. Imagine you are an astronaut falling toward the event horizon. From your perspective, you fall in. You cross the darkness, you see the interior, you die. But from the perspective of someone watching from the outside, you never cross the horizon. As you get closer to the black hole, the light coming from your body gets stretched. Time slows down. To the outside observer, you appear to freeze just above the surface. You get flattened. You get smeared across the horizon like a layer of paint. The heat of the horizon scrambles your atoms, turning you into a soup of data. So where are you? Are you inside the black hole, or are you flattened on the surface? The holographic principle says, you are both. This leads us to the most profound realization in modern cosmology. The capacity of a black hole to store information is not determined by its volume. It is determined by its surface area. Let me repeat that, because it defies all intuition. In our normal three-dimensional world, volume is king. If you have a box that is 1 meter wide, it can hold a certain amount of stuff. If you make the box 10 times wider, its volume increases by a factor of 1,000. You can fit 1,000 times more stuff inside. We naturally assume that the amount of reality a space can hold depends on how deep it is. But black holes do not follow this rule. If you take a black hole and pump more matter into it, it grows. But its information content, its entropy, grows only in proportion to the surface area of the event horizon. The interior volume is mathematically irrelevant. It is redundant. Think of a library. Imagine a library where the number of books you can fit inside doesn't depend on how many shelves are in the rooms. Instead, it depends on how many square inches of paint are on the walls outside the building. That is a black hole. The inside of the black hole is a projection. It is a hologram generated by the data written on the surface. This solved the paradox. The information isn't lost because it never truly leaves the surface. When the black hole evaporates, that data on the surface is released back into the universe. The diary is safe. Physics is saved. But the cost of this victory was our understanding of reality. Because if this math works for black holes, why wouldn't it work for everything else? A black hole is not a special magical object made of different stuff. It is just gravity and space pushed to their limits. If the most extreme object in the universe follows the holographic principle, then the universe itself must follow it. We are currently sitting inside a room. You perceive this room as having volume. You feel the air between you and the walls. But if the holographic principle is correct, this volume is an illusion. The information describing you, your computer, your thoughts, and the stars outside is not here. It is painted on a distant boundary. We are living inside a cosmic soup can. The label on the can is the true reality. It is a two-dimensional shell of data fields buzzing with quantum interactions. The soup inside, the three-dimensional world of galaxies and gravity and people, is just the visual output of that data. We are the projection. This changes the question of what is the universe. It is no longer a physical place. It is a processor. It is a mechanism that converts two-dimensional information into three-dimensional experience. And like any processor, like any screen, it has a limit. A screen is made of pixels. You cannot have an image sharper than the pixels allow. If the universe is a projection, then space itself must be pixelated. It cannot be infinitely smooth. If you zoom in far enough, past the atoms, past the protons, past the quarks, you must eventually hit the grid. You must eventually hit the bottom of the simulation. And incredibly, we may have already found the size of that pixel. In the next part, we will descend into the microscopic. We will look for the grain of the cosmos. We will explore the Planck length, the noise of space-time, and the terrifying possibility that our reality has a maximum resolution. Because if the universe has pixels, then the universe is computable. And if it is computable, who is the computer? How sharp is reality? Look at the screen in front of you. You know that the image you are seeing is a trick. It looks like a smooth, continuous picture. But if you take a magnifying glass and get close enough, the illusion breaks. You see the grid. You see the red, green, and blue dots. You see the pixels. You know that the image is not infinite. It has a limit. It has a resolution. But when you look away from the screen, when you look at your own hand or the wall or the stars, you assume the rules are different. You assume that the real world is smooth. You intuitively believe that if you had a microscope powerful enough, you could zoom in forever. You could find atoms, then protons, then quarks. And inside the quarks you would find smaller things, and inside those, even smaller things. We believe that space is a continuum, an endless, seamless fabric that can be divided infinitely without ever hitting a bottom. But physics suggests that this belief is a hallucination. If the holographic principle is true and the universe is a projection of information, then the universe must be digital. It cannot be analog. Information is made of bits, zeros, and ones, discrete chunks of data. You cannot have half a bit of information. And if the universe is made of bits, then space itself must be made of chunks. We have found the size of the pixel. It is called the Planck length. To understand how small this is, we have to stretch our imaginations until they snap. An atom is small. We all know that. But compared to the Planck length, an atom is a galaxy. Imagine a single dot printed on a piece of paper. Now, imagine magnifying that dot until it is the size of the entire observable universe. Inside that universe-sized dot, the Planck length would be a single dot. It is 10 to the power of negative 35 meters. It is a decimal point followed by 34 zeros and a 1. This is not just small, this is the brick wall of reality. According to our current understanding of physics, it is impossible to measure anything smaller than this. It is impossible to separate two locations that are closer than this. It is the absolute limit of resolution. If you were to try to look at something smaller than the Planck length, you would need a photon of light with so much energy that it would collapse into a tiny black hole. The act of looking would destroy the thing you are looking at. This tells us something profound. The universe is not smooth. It is granular. Space is not a continuous fluid. It is a lattice. It is a grid. When you move your hand through the air, it is not sliding smoothly through existence. It is jumping. It is teleporting from one Planck-sized cell to the next, like a chess piece moving across a board. It happens so fast and the cells are so small that it feels smooth to you. But at the fundamental level, motion is a series of snapshots. And here is where the story gets unsettling. Because we might have already heard the grid. In the countryside of Germany, near the city of Hanover, there is a machine called GEO 600. It is a gravitational wave detector. It is designed to listen to the faintest ripples in the fabric of space-time, caused by colliding black holes billions of light years away. It is one of the most sensitive ears humanity has ever built. For years, the scientists running GEO 6 were plagued by a problem: noise. No matter how much they isolated the machine, no matter how much they shielded it from vibrations, wind, and temperature changes, there was always a persistent, mysterious static in the signal. A hum that wouldn't go away. They checked the lasers, they checked the mirrors, they checked the vacuum tubes. Everything was perfect, but the hum remained. Then, a physicist named Craig Hogan approached them with a chilling theory. He suggested that the machine wasn't broken. He suggested that the noise wasn't coming from Earth. He proposed that GEO 600 had hit the limit of the universe's resolution. Imagine zooming into a digital photo too much. Eventually, the edges get blurry. You see pixelation artifacts. Hogan suggested that the mystery noise was exactly that. It was the quantum jitter of space-time itself. The machine was so sensitive that it was detecting the granularity of the hologram. It was hearing the static of the cosmic hard drive. If this is true, it changes everything. It confirms that information is finite. Think about what that means. If space is made of a finite number of pixels, then there is a maximum amount of information that can exist in any given volume. A room can only hold so many positions. A brain can only hold so many states. This is called the Bekenstein bound. It is the absolute storage limit of nature. And this limit is the smoking gun of the holographic principle. Because the limit isn't huge, it implies that the universe is efficient. It implies that the universe doesn't waste memory. If we live in a pixelated reality, we have to ask the question, why? Why would nature chop itself up into tiny blocks? Nature usually loves curves, it loves waves, it loves flow. The only things that use pixels, the only things that use discrete grids, are things that are computed. A computer cannot handle infinity. A computer cannot calculate a truly smooth curve. It has to approximate it with tiny straight lines. A computer cannot simulate a truly infinite space. It has to break it down into a mesh. The fact that our universe has a minimum size is a strong indicator that our reality is a product of computation. We are living in a low-resolution simulation that looks high-resolution because we are too big to see the dots. We are Mario running through the Mushroom Kingdom, thinking the ground is solid, unaware that we are just a collection of sprites jumping over a grid of code. But if space is a grid, where is the grid located? We said earlier that the information is stored on a distant boundary. But how does a 2D boundary create a 3D grid? How does the flat data become the deep world? To answer this, we have to step out of the universe entirely. We have to look at the bottle from the outside. We have to talk about the strange, impossible geometry where this hologram lives. We have to talk about the boundary of the snow globe. Because the pixels of space are not just sitting there, they are entangled, they are talking to each other. And it is this conversation, this quantum whispering between the pixels, that creates the greatest illusion of all, the illusion of gravity. In the next part, we will explore the boundary. We will learn how a flat ocean of data can boil up into a mountain of space, and we will find out why you are glued to the floor right now. Hint: it is not because the Earth is pulling you, it is because the computer is optimizing its code. We have looked at the black hole, and we have looked at the pixel. We have seen the evidence that reality is granular and that information lives on the surface, not in the deep. But now we must ask the biggest question of all. If the universe is a hologram, where is the film? Where is the screen? And where, exactly, are you? To answer this, we have to travel back to 1997. A physicist named Juan Maldacena made a discovery that was so mathematically perfect, so elegant, that it stunned the scientific community. It was called the AD-CFT correspondence. The name is technical, dry, and uninspiring, but the meaning is magical. Maldacena proved mathematically that a universe with gravity, a universe deep and rich and three-dimensional like ours, is identical to a universe without gravity that exists in only 2 dimensions. He proved that they are not 2 different universes. They are the same universe, described in 2 different languages. This is hard to visualize, so let us build a model in your mind. Close your eyes and imagine a snow globe, a beautiful glass sphere sitting on a table. Inside the sphere, there is a little world. There are snowflakes falling. There is a house. There is a snowman. There is empty space between the flakes. This interior space, the volume inside the glass, is called the bulk. In this analogy, the bulk is where we think we live. It is the world of 3 dimensions. It is the world where you can move up, down, and forward. It is the world where gravity exists, pulling the snowflakes down to the floor of the globe. Now, look at the glass shell, the boundary, the surface of the sphere. This surface is 2-dimensional. It has no depth. You can only move along the curve, north, south, east, or west. Maldacena's theory suggests that the real physics, the source code of reality, is happening on the glass. Imagine that the glass shell is a screen. On this screen, there are quantum fields flashing and buzzing. There are particles interacting, but they are trapped on the surface. They cannot enter the sphere. However, the interactions on the surface create a projection. They cast a shadow into the center of the globe. When a quantum field ripples on the glass, a particle pops into existence inside the globe. When 2 ripples on the glass crash into each other, 2 planets inside the globe collide. The drama inside the snow globe, the gravity, the motion, the depth, is just a holographic movie generated by the flat, chaotic activity on the boundary. This brings us to a terrifying realization about your own location. You feel like you are inside the bulk. You feel like you are sitting in a room surrounded by air. But if this theory is correct, you are not inside the globe. You are painted on the glass. Every memory you have, every thought firing in your brain, every beat of your heart is actually a complex pattern of data processing occurring on the distant 2-dimensional edge of the universe. The you that is sitting in the room is just the avatar. It is the character on the screen. The player, the physical substance of your existence, is flattened on the wall of the cosmos, billions of light years away. We are ghosts in a machine. We are the 3D shadows of a 2D reality. This equivalence is precise. Physicists have found that difficult problems in the 3D world can be solved easily in the 2D world, and vice versa. For example, if you want to understand a black hole in the 3D world, which is incredibly complex. You can translate it to the 2D boundary. And on the boundary, the black hole isn't a monster of gravity. It is just a hot soup of fluid. You can do the math on the fluid, translate it back, and understand the black hole. It works perfectly, too perfectly to be a coincidence. Nature does not build intricate mathematical bridges between two worlds, unless those two worlds are the same thing. But this leads to a mystery. If the true reality is the flat chaotic data on the boundary, why do we see the illusion? Why does the hologram pop up? Why doesn't the universe just stay flat? What is the mechanism that inflates this flat data into a massive, deep, three-dimensional balloon? The answer is perhaps the strangest part of the story. The force that blows up the balloon, the force that creates the illusion of here and there, is something we usually think of as a force of attraction. It is gravity. But not the gravity you learned about in school. In the holographic view, gravity is not a fundamental force. It is not a thing that exists on the boundary. Gravity is a side effect. It is what happens when the information on the boundary gets entangled. It turns out that distance in our world is just a measure of entanglement in the data world. 2 points in space are close to each other, not because they are physically near, but because their data on the hard drive is linked. If you destroy the link, the space between them rips apart. Spacetime is stitched together by quantum threads. In the next part, we will expose the great lie of gravity. We will explore why gravity is the weakest force in the universe and why that weakness is the ultimate proof that it isn't real. We are going to look at the threads that hold the hologram together and ask what happens when they start to unravel. You are not being pulled down by the earth. You are being computed. There is a simple experiment you can do right now that will prove, beyond a shadow of a doubt, that the universe is broken. Go to your kitchen, find a magnet. It can be a cheap souvenir magnet on your refrigerator or a tiny magnet from a toy. Now, place a paperclip on the table. Hold the magnet over the paperclip. Watch as the metal shutters, lifts off the table and snaps onto the magnet. It looks boring. It looks mundane. But think for a second about what just happened in that battle. On one side, you have the entire planet Earth, a ball of rock and iron measuring 12,000 kilometers across, a monster weighing 6 septillion kilograms. The Earth is pulling down on that paperclip with the combined gravitational might of every mountain, every ocean, every continent, and a spinning molten core. On the other side, you have a piece of magnetic tape the size of your fingernail. And the magnet wins. Effortlessly. The tiny magnet defeats the entire planet. This simple observation reveals a secret that has kept physicists awake at night for a century. Gravity is pathetic. It is shockingly, confusingly, insultingly weak. If you compare the strength of the electromagnetic force holding your atoms together against the strength of gravity pulling you down, the difference is not double. It is not triple. It is a number so large it creates a sense of vertigo. Gravity is 10 to the power of 40 times weaker than electromagnetism. That is a 1 followed by 40 zeros. To give you a sense of scale, if gravity were the size of a single hydrogen atom, the electromagnetic force would be larger than the observable universe. This is known as the hierarchy problem, and in a universe that is supposed to be elegant, mathematical, and balanced, this discrepancy is ugly. It feels like a mistake. Why would nature create 4 fundamental forces, make 3 of them incredibly powerful, and leave the 4th one, gravity, as a whispering ghost? For decades, we tried to fix this by looking for the particle of gravity. We found the photon, which carries light. We found the gluon, which holds the nucleus together. We found the W and Z bosons, which govern radioactive decay. So we assumed there must be a graviton, a tiny particle that flies between objects and creates the pull of gravity. We built collider machines costing billions of dollars. We smashed atoms together at the speed of light. We sifted through the debris. We found nothing. The graviton is missing. It is the ghost in the machine. And now, thanks to the holographic principle, we are beginning to understand why we can't find it. We can't find the graviton because it doesn't exist. Gravity is not a fundamental force. Gravity is not a thing that lives at the bottom of reality. Gravity is a lie. It is what physicists call an emergent phenomenon. To understand emergence, we have to look at something you experience every day: heat. Imagine you are holding a cup of hot coffee. You feel the warmth transferring to your hand. You can measure the temperature with a thermometer. It feels real. It feels like a physical substance flowing from the cup to you. But if you were to shrink yourself down to the size of an atom and dive into the coffee, you would not find a heat particle. You would not find a molecule of temperature. You would only find atoms moving fast. Heat is not a fundamental ingredient of the universe. Heat is just a description. It is a statistical average of the chaotic motion of billions of atoms. Temperature emerges from the chaos. It is a useful illusion that describes the behavior of the crowd, but it does not exist for the individual. The holographic principle suggests that gravity is exactly the same thing. Gravity is the heat of the universe. It is not a force field that reaches out and grabs you. It is a side effect. It is the statistical result of the information on the 2D boundary processing data. This theory, known as entropic gravity, was championed by physicist Eric Verlande. He proposed that the universe, like a gas, always wants to increase its entropy. It wants to increase its disorder. It wants to maximize its options. When you stand up, you are resisting gravity. But in Verlande's view, you are not fighting a force. You are fighting entropy. Imagine the space around you is filled with information. When a massive object like the Earth sits in space, it distorts the information flow. It reduces the entropy in its vicinity. The universe hates this. The universe wants to restore the entropy. It wants to scatter the information. The most efficient way to maximize the entropy is to push matter together. So, the force you feel pulling you to the floor is not a pull at all. It is the tendency of the system to seek its most probable state. You are not falling because of gravity. You are falling because of probability. You are falling because nature is trying to scramble its data more efficiently. This explains why gravity is so weak. It is weak because it is a residue. It is the leftover noise of the quantum processing happening on the boundary. When you lift that paperclip with the magnet, you are pitting a fundamental force of nature, electromagnetism, against a mere statistical tendency. It is like a soldier fighting a ghost. The soldier wins every time. But if gravity is an illusion, then what holds the universe together? If there is no force tying the stars to the galaxies and the planets to the stars, why doesn't everything just drift apart into a chaotic mess? The answer lies in the threads that stitch the hologram itself. The answer is quantum entanglement. We have spoken about the 2D boundary, the shell of the snow globe where the real data lives. This boundary is composed of pixels of information. But these pixels are not independent. They are talking to each other. They are linked. In quantum physics, this link is called entanglement. It is the famous spooky action at a distance. When two quantum bits are entangled, they lose their individual identity and become part of a single system. In 2010, a physicist named Mark van Ramsdonk proposed a mind-bending idea. He suggested that spacetime is entanglement. Imagine two pixels on the distant boundary. If they are not entangled, they are separate. There is no connection between them. But the moment they become entangled, a thread of proximity is formed. A bridge is built. In the holographic projection, in the 3D world where we live, this entanglement manifests as distance. 2 points are close to each other in our room, not because they are physically near, but because their source code on the hard drive is highly entangled. If you entangle a billion pixels, you weave a billion threads. These threads knit together to form a continuous, smooth fabric of geometry. The empty air in front of your face is not empty. It is a dense web of quantum correlations. It is a network of active links maintaining the illusion of volume. But this model leads to a terrifying thought experiment. What happens if we cut the threads? Imagine a godlike being who could reach into the boundary and turn off the entanglement, one by one, breaking the links between the pixels. What would happen to our universe? In a standard universe held together by gravity, things would just drift away. The planets would fly off into the dark. But in a holographic universe built by entanglement, the result is far worse. If you cut the threads, space itself disappears. The distance between the Earth and the Sun would not become infinite. It would become undefined. The concept of between would cease to exist. The universe would not explode. It would fragment. It would shatter into billions of isolated, lonely islands of reality. Each atom would become its own separate universe, unable to communicate with its neighbor. Reality would dissolve into a cloud of disconnected data points. This is the true nature of the eternal prison we talked about. We are confined not just by the speed of light, but by the network coverage of the entanglement. We can only exist where the threads are woven. So when you feel the weight of your body pressing into the chair, do not think of it as gravity. Think of it as the tension of the network. You are sitting in a gravity well, which means you are sitting in a region of high complexity, a region where the computer is working the hardest. Gravity is the fan noise of the cosmic GPU. It is the heat generated by the processing of your existence. This realization strips away the physicality of our world. We used to think that matter was the main character and space was the stage. But now we know that space is just a projection of code and gravity is just an artifact of the compilation. If the stage is a lie and the force holding the stage together is a lie, then what does that make the actor? What does that make you? You think you are made of solid stuff. You think you are made of protons, neutrons, and electrons. You think you have mass. But mass is just resistance to movement, and movement is just a translation of data across the grid. If we peel back the final layer of the onion, we arrive at the most philosophical and the most disturbing conclusion of the holographic principle. In the 1980s, the legendary physicist John Wheeler, the man who coined the term black hole, came up with a phrase that summarizes the ultimate truth of our reality. It from bit, 3 simple words, but they imply a universe that is completely non-physical. It, the particle, the atom, the chair, the person, comes from bit, the binary unit of information. The universe is not made of energy. It is not made of matter. At its absolute core, beneath the quarks, beneath the Planck length, beneath the geometry, the universe is made of yes and no, 1 and 0. We are not the users of this computer. We are not the programmers. We are the software. And this changes everything about how we see ourselves. A software file does not have a location. It has an address. A software file can be copied, it can be compressed, and, most frighteningly, it can be deleted. In the next part, we will explore the implications of being made of code. We will ask if the laws of physics are fixed or if they are just patches and updates released by the system. And we will look for the glitches, the moments where the rendering engine fails, the moments where the mask slips and we see the raw data underneath. You are not a body with a soul. You are a packet of information struggling to survive in a noisy channel. Gravity is a lie. But the code is real. What are you made of? If you ask a biologist, they will tell you that you are made of cells, proteins, and DNA. If you ask a chemist, they will tell you that you are made of carbon, hydrogen, oxygen, and nitrogen. If you ask a physicist from the 20th century, they will tell you that you are made of atoms, electrons, and quarks. But if you ask a physicist working on the holographic principle today, they will give you a different answer. An answer that is colder, more abstract, and infinitely more terrifying. They will tell you that you are not made of matter. You are not made of energy. You are made of yes and no. You are a sequence of binary choices. A quark is here or it is not here. A spin is up or a spin is down. A field is excited or it is dormant. At the absolute bottom of reality, beneath the vibrations of the strings, beneath the pixelation of the Planck length, there is no stuff. There is only questions and answers. There is only information. This is the doctrine of it from bit. The legendary physicist John Wheeler proposed this idea as a final roadmap for physics. He realized that the universe is not a machine made of gears and levers. It is not a clockwork mechanism as Isaac Newton believed. The universe is a processor. It is a computer. And existence, physical, tangible existence, is just the output of a computation. When you look at a digital photograph, you see a smiling face, you see colors, you see emotions. But the computer does not see a face. The computer sees a long, boring string of zeros and ones. The face is an emergent property. It is a hallucination generated by the arrangement of the data. Wheeler suggests that the universe is exactly the same. The chair you are sitting on, the air you are breathing, and the hand you are holding. These are the user interface. These are the smiling face. The reality is the code underneath. But if this is true, if the universe is mathematically indistinguishable from a computer simulation, shouldn't we be able to find the code? Shouldn't we be able to dig into the equations of nature and find the fingerprints of a programmer? In the early 2000s, a theoretical physicist named Sylvester James Gates found something that made his blood run cold. He was working on superstring theory, trying to describe the fundamental particles of the universe using complex mathematics known as adinkras. These are geometric symbols that represent the equations of supersymmetry. As he analyzed the structure of these equations, he noticed a pattern that looked familiar. It wasn't a pattern from physics. It wasn't a pattern from biology. It was a pattern from computer science. Deep inside the equations that describe the fundamental fabric of our reality, Gates discovered doubly even self-dual linear binary error-correcting block codes. That is a mouthful. But you know what this is. You use it every day. It is the same type of code that Claude Shannon discovered in the 1940s. It is the code used in your web browser to ensure that data is transmitted correctly. It is the code used to fix scratches on a CD or corruption on a hard drive. Error-correcting code is a specific, highly artificial mathematical structure designed to protect information from noise. It does not appear in nature by accident. You do not find error-correcting codes in the shape of a cloud or the flow of a river. It is a tool of engineering. It is a signature of intelligent design, or at least of algorithmic architecture, and yet there it was, written into the fundamental rules of the cosmos. This discovery forces us to confront a possibility that sounds like madness. We are living in a system that is built to resist corruption. The universe has a checksum. It has a mechanism to prevent the data of reality from degrading. Why would the universe need error correction? A biological universe doesn't care if it mutates. In fact, biology relies on mutation. But a computational universe relies on precision. If a single bit flips in a computer program, the whole system can crash. The blue screen of death. Perhaps the laws of physics, the speed of light, the gravitational constant, the charge of the electron are not arbitrary numbers. Perhaps they are the parameters set by the system to keep the simulation stable. They are the config file of reality. This changes the way we look at everything. Take the second law of thermodynamics. It states that entropy always increases, things break down, energy spreads out, order turns into chaos. In the physical view, this is just the inevitable decay of matter. But in the it-from-bit view, this is something else entirely. This is bit rot. Every computer user knows that data degrades over time. Files get corrupted, hard drives fail. The expansion of the universe and the increase of entropy might just be the accumulation of rounding errors in the cosmic calculation. We are slowly becoming glitchy. The universe is getting older, not because time is passing, but because the error-correcting codes are being overwhelmed by the noise. And what about you, the observer? If the universe is a computer, what is your role? Are you the user, or are you part of the program? Quantum mechanics tells us that the observer is special. When you look at an electron, it decides where to be. When you don't look, it is a wave of probability. It is everywhere and nowhere. This behavior is suspiciously similar to lazy loading in video games. In a video game, the computer does not render the entire world at once. That would waste processing power. It only renders what you are looking at. The room behind you does not exist until you turn around. Quantum physics suggests our reality works the same way. The universe does not calculate the specific position of a particle until it needs to, until a conscious observer demands an answer. We are the cursors. We are the read-write heads of the Turing machine. Our consciousness is the trigger that forces the code to compile into reality. Without us, without the observer, the universe would remain a dark, silent ocean of abstract data. It would be a hard drive that is never read. But this brings us to the most existential horror of the holographic universe. If you are just a pattern of information, can you be copied? In classical physics, cloning is easy. You just arrange atoms in the same way. But in the quantum world, there is a rule called the no-cloning theorem. It states that it is impossible to create an identical copy of an arbitrary unknown quantum state. You cannot copy and paste a soul. To copy quantum information, you have to extract it, and extracting it destroys the original. This is known as teleportation. We can teleport an atom from A to B, but in doing so, the atom at A ceases to exist. This suggests that your identity is tied to a unique instance of data processing. You are a single, continuous thread of execution. But what happens when the thread ends? What is death in a digital universe? If you are a biological machine, death is the breakdown of the hardware. The gears stop turning. But if you are software, death is simply the deletion of the pointer. The data might still be there, scattered across the holographic boundary, but the program that organizes it has stopped running. Or perhaps it is uploaded. The law of conservation of information, the law that saved us from the black hole paradox, says that information cannot be destroyed. This means that the data that makes up you can never be deleted from the universe. It is permanently written onto the cosmic hard drive. The signal may fade, the encryption key may be lost, but the file remains. This is a strange kind of immortality. It is not the immortality of angels and clouds. It is the immortality of a backup archive. You are a record, a log entry in the universal calculation, and this leads to the final burning question. If the universe is a computer and we are the code, what is the calculation for? A computer does not run for no reason. It runs to solve a problem. It runs to find an answer. Is the history of our universe, the Big Bang, the formation of stars, the evolution of life, the wars, the love, the suffering, just a long, complex simulation trying to solve a single mathematical equation? And if so, what happens when the answer is found? What happens when the progress bar reaches 100%? Does the simulation restart? Does it shut down, or does it level up? We are nearing the end of our journey. We have dismantled the illusion of depth. We have seen the pixels. We have touched the boundary. We have exposed gravity as a lie, and we have accepted our nature as code. Now, there is only one thing left to do. We must face the end. In the final part, we will look at the future of the hologram. We will look at the heat death of the universe, not as a tragedy, but as the completion of the program. And we will ask the question that haunts every character in every story. Is there a player holding the controller? Every computer program, no matter how complex, has a final line of code. Every simulation has a shutdown sequence. And if the holographic principle is true, our universe is no exception. We look at the night sky and we see eternity. We intuitively feel that the stage is permanent. We think the stars will burn forever, that the galaxies will dance forever, and that time itself is an infinite road stretching out before us. But thermodynamics tells a different story. Thermodynamics tells us that the computer is running on a battery, and the battery is draining. The universe is dying. Slowly, irreversibly. We are currently living in what cosmologists call the stelliferous era, the era of stars. It is a time of light, heat, and energy. Heat, It is the high-performance mode of the simulation. But this era is a brief flash in the pan, a momentary spark in the dark. Soon, relatively speaking, the gas clouds needed to form new stars will be exhausted. One by one, the fusion reactors that light up the void will sputter and choke. The red dwarfs will fade into white dwarfs. The white dwarfs will cool into black dwarfs. The universe will turn off the lights. In the standard view of physics, this is called the heat death. It is a tragedy. It is the slow, agonizing fade into cold, dark, absolute nothingness. But in the view of the holographic universe, this is not a death. It is a completion. Think about a computer processing a massive, complex file. Think about a video rendering engine. When the fans spin, when the heat rises, when the processor screams, that is the machine working. That is the machine thinking. That is the struggle to calculate the answer. But when the calculation is done, the heat stops. The fans spin down. The screen goes dark. The silence returns. The silence at the end of time is not failure. It is the moment the progress bar hits 100%. It is the moment the equation is solved. So we must ask the question that lies at the heart of existence. What was the calculation for? Why build a hologram of such staggering scale? Why simulate a universe with billions of galaxies, trillions of years of history, and infinite complexity just to end in silence? There are two terrifying possibilities. The first possibility is that we are a Monte Carlo simulation. In science, when we cannot solve a complex problem with a simple formula, we run a simulation. We throw random variables into a computer and let them interact millions of times to see what happens. Perhaps the programmer, whatever intelligence created the boundary, is trying to solve a problem we cannot comprehend. Perhaps they are trying to figure out how life begins or how gravity interacts with quantum mechanics. We are not the purpose, we are the test data. Our wars, our loves, our art, our suffering, these are just the variables in the algorithm. We are the crunching of the numbers. But there is a second possibility. A possibility that is more poetic and far more haunting. Perhaps the purpose of the simulation is memory. Some physicists, like Perimeter Institute's Nyayesh F. Shorty, have proposed a radical theory about the origin of our holographic boundary. They suggest that our Big Bang was not a random accident. They suggest it was the result of a star collapsing in a higher dimensional universe. Imagine a universe with 4 spatial dimensions. A 4D star in that universe runs out of fuel and collapses into a 4D black hole. Just as a 3D black hole has a 2D event horizon, a 4D black hole would have a 3D event horizon. We might be that horizon. Our entire universe might be the ash of a dead star from a higher realm. We are the debris field. We are the holographic record of everything that fell into that 4D monster. If this is true, then we are literally a ghost story. We are the preserved information of a world that no longer exists. We are the memories of the ancestors digitized on the edge of the abyss, replaying our history in a loop of holographic light. We are not being simulated to solve a problem. We are being simulated so that we are not forgotten. This changes the way we look at consciousness. If the universe is a hard drive full of data, what is the role of the conscious observer? What is the role of you? Information, by itself, is meaningless. A book that is never opened is just a block of wood and ink. A hard drive that is never read is just a brick of magnetic dust. Data requires a reader. It requires an interpreter. A movie on a reel is just plastic tape. It needs light to pass through it. It needs a screen. And most importantly, it needs an audience. We are that audience. We are the mechanism by which the universe reads its own data. The 2D boundary, that distant shell at the edge of the cosmos, is a cold, chaotic ocean of math. It is abstract. It is binary. It has no color. It has no love. It has no pain. It has no music. But when that data is projected into the 3D bulk, when it is filtered through a human brain, it gains texture. It gains qualia. We turn the raw binary code of the cosmos into the sensation of a cold wind on your face. We turn the frequency of a photon into the color blue. We turn the vibration of air molecules into the sound of a violin. We are the translators. We are the user interface of reality. Without us, without the hologram, the data is dead. It is static. We are the ones who bring the ghost to life. We are the processing nodes that allow the universe to feel itself. But this brings us back to the haunting question of the real. If you are a hologram, does that mean you are fake? Does it mean your life is a lie? When you look in a mirror, the reflection is not real. It consists of photons bouncing off silver-coated glass. You cannot touch the person in the mirror. You cannot shake their hand. But the person in the mirror is tied to something real. The reflection proves the existence of the original. If we are the reflection, then what is the original? What is the thing on the boundary that is casting the shadow of you? Is it just a random cluster of quantum fluctuations, or is there something more structured out there? The holographic principle implies a terrifying unity. In the 3D world, we are separated. I am here, and you are there. There is empty space between us. There are walls. There are oceans. We feel alone. But on the boundary, on the source drive, there is no distance. The concept of spatial separation does not exist in the same way. The data that makes up your heart and the data that makes up the heart of a person on the other side of the planet might be sitting right next to each other on the hard drive. In fact, thanks to entanglement, they might be the same data, accessed from two different addresses. This means that separation is the greatest illusion of all. We are not billions of separate beings fighting for survival. We are a single, vast, interconnected field of information, experiencing itself from billions of different perspectives. The walls between us are just lines drawn in the hologram. In the code, we are one. So how do we live with this knowledge? How do you go to work tomorrow, pay your bills, worry about the future, and love your family, knowing that you are a rendering, knowing that gravity is a lie and space is a pixelated grid? You live the same way you watch a movie. When you watch a great film, you know it isn't real. You know the actors aren't really dying. You know the music is just speakers vibrating. You know the screen is flat. But you cry anyway. You laugh anyway. You let your heart race. You let yourself be swept away by the story. Why? Because the story is what matters. The medium is irrelevant. The emotions are real. The connections are real. The consciousness is real. The platform might be synthetic, but the user experience is authentic. René Descartes, the father of Western philosophy, famously said, "I think, therefore I am." In the age of the holographic universe, we must update this. We must say, "I render, therefore I am." We have reached the end of our journey through the cosmic cage. We started by questioning the depth of the world. We peered through the bars of perception. We zoomed in until we saw the pixels of the Planck length. We touched the cold glass of the boundary. We exposed gravity as a side effect of entropy, and we accepted our nature as it from bit. And now it is time to close the program. The universe will continue its calculation. It will continue to process the bits, creating galaxies and stars and worlds until the final line of code is executed and the screen goes dark. But for you, the observer, the simulation pauses whenever you choose. Tonight, when you lay your head on the pillow and close your eyes, you are doing something profound. You are turning off the rendering engine. You are ceasing to collapse the wave functions. You are withdrawing your consciousness from the interface. Do not be afraid of the dark. The dark is not death. The dark is just the screen in standby mode. The dark is where the system rests. The data is safe. The memory is written. The information is conserved. You are part of the permanent, indestructible record of existence. You are a line of code that can never be deleted. Sleep well, Shadow. The projection will be waiting for you when you wake up.